Okay, in this video I want to talk about the standard form of a quadratic function, also known as the vertex form of a quadratic function. And that's actually the second one. The top one is the way we're more used to seeing it, but the bottom one is what's called standard form for some reason. So this bottom one is what's called the standard form, or the vertex form. The relationship between the two is that, it uses the same number a, and this h and k are actually the coordinates of the vertex. So, from the previous video, we know that the relationship between ABC and h and k is that h is minus b over 2a, a part of quadratic formula without a square root, and k is f of h. Okay, so this is the relationship between the two. H and k are the vertex. Okay, so let's write down an example. I'm going to look at the function 2x squared minus 12x plus 19. And I'm going to talk about two different ways to turn this into standard form or vertex form. Okay, the first way is something we've seen before, which is completing the square. If I complete the square and somehow turn x squareds and x's into something in parentheses quantity squared, then it should look like the standard form or the vertex form. So I'm going to try and do completing the square, but it's going to look a little bit different than what we've seen before. Okay, so when we saw completing the square before, our instructions were get the x's together, or get the x's by themselves. And so, if I was solving an equation using completing the square, I would subtract 19 to the other side. I don't want to do that though, because my goal is to turn this equation into this equation. Notice they have the same left-hand side, f of x. I don't want to mess with the left-hand side. I want to leave this equation as f of x equals expression. So I'm going to try and change that expression, complete the square on it, and yet still keep it equal to f of x. So all of my steps, I'm going to have f of x equals something. And so we're going to have to kind of be creative in how exactly we do the same steps that we did before for completing the square, now that we're restricted to trying to keep the left-hand side as f of x. Okay, so instructions were to get the x's by themselves. So if I can't subtract 19, maybe I can just put parentheses around the x's. And then inside the parentheses, I got the x's by themselves. So maybe that's good enough. We'll try it. Second set of instructions is get rid of the lead coefficient. And again, if this is an equation that I was trying to solve, I would divide both sides by 2. It would be really easy. It would be simple. I would love it. But we're not trying to solve for x. We're not using completing square for that reason. So instead of dividing both sides by 2, because again, that would mess up my left-hand side. Instead, I think I want to factor a 2 out of the entire quantity in parentheses. So I'm going to make this 2 times the quantity x squared minus 6x. And my 19 I'm not changing. Okay, so just at every point, make sure we look back at our previous steps. Is this equivalent to the previous step? Yes, it is. You would distribute a 2, and you get exactly this expression. Okay, so get the x's by themselves, factor out or get rid of any lead coefficient. Those are the 2 setup steps. Next step is take the x coefficient, divide it by 2, and then square it. So negative 6 divided by 2 would be negative 3, and then we square it to get plus 9. Okay, so I would love to have 2x squared minus 6x plus 9 inside the parentheses. Slight issue, I'm not allowed to just add 9 whenever the heck I want to add 9. So, ways that we can deal with this is we can try and see, well, what number should go here so that when I distribute, I get the same answer as the previous step. You can think about it that way if you want. It ends up, it's going to be a 1. Alternatively, we can think about it this way. I added a 9. I have to undo that. I need to counteract it. If I put 9 on the scales on the left side, I need to put another 9 on the scales on the other side. So if I'm adding 9, I should probably also subtract 9. So the 9 and the minus 9 should maybe cancel out. Maybe. If you notice, if you distribute this, we have 2x squared minus 12x plus 18 plus 19 minus 9. So we didn't actually add a 9 because of this 2. We actually have a 2 times a 9, which is an 18. So when I put this plus 9 in, I actually added 18 to the original expression. So if I'm going to balance out the scales, I need to also subtract 18. And so this is the step that's a little fuzzy, it looks weird, but if you distribute out this line, you will see 2x squared minus 12x plus 18 plus 19 minus 18, and the two 18s will cancel and you'll get back exactly what we started with. So it feels a little weird, but what we ended up doing was we're multiplying this number and this number to say what did we actually add, which was an 18, and then I better subtract it as well so that I don't tip the balance on the scales. Okay, anyway, if I did that right, then the thing in parentheses should be a perfect square. And 19 minus 18 is 1. Okay, so we have turned our parabola, or our quadratic function, into standard form. And so this is now a parabola with a is 2, h, let's see, it's x minus h, so I guess h is positive 3, and k is 1, so our vertex is 3, 1. Okay, so you're sitting in your chair and you're thinking to yourself, I hate that, I never want to do that again. Okay, let's think about another option. I was using completing the square as a way to turn us from one form of the equation to the other form of the equation, then we can find the vertex. Alternatively, we have a formula for the vertex. Why don't I just find the vertex first, and then write my answer in this weird standard form or vertex form? That is also okay. The only downside there is that we are going to have to memorize this formula, but we'll probably need to learn it anyway, so it's not like it's terrible. I did want to show you the algebraic way to solve it, but we also have another option. So, method 2. Given f of x is equal to 2x squared minus 12x plus 19, I spot a, b, and c. A is 2, b is negative 12, c is 19, but I'm not really worried about c right now. Just from those two, I can say that h is minus b divided by 2 times a, which is a positive 12 over 4, or 3. Convenient. That was the same h we got from this more complicated way. K is the corresponding y value, so k is f of h, which means we're going to take our h3 and plug it into the function. So 2 times 3 squared minus 12 times 3 plus 19. 3 squared would be 9 times 2 is 18. Minus 12 times 3 is 36 plus 19. 18 minus 36 is negative 18. Negative 18 plus 19 is 1. Which is the same answer we got the other way. K is 1. Okay, so if I know A is 2, H is 3, and K is 1, then all I have to do is plug into this formula. Well, remember the formula and then plug into it. And so I would get f of x is equal to A, 2, parentheses, x minus h, 3, squared, plus k, which is 1. So notice we got the same answer. The only thing that seems a little different is instead of getting a formula first and then finding the coordinates of the vertex, we found the coordinates of the vertex first and then plugged in to find a formula. Either way is acceptable. I'm not going to say you have to do the problem one way or the other way. Pick your favorite. Again, I would probably pick the way on the right. The only downside is you're going to have to learn the formulas. If you complete the square, it's basically you learn one method, which is a variation on something we've seen before, and just complete it. Anyway, let's try an example where we work in the opposite direction. I'll give you a vertex form of a parabola, and we'll try and find the ax squared plus bx plus c form. So I'm going to use negative 3x plus 1 squared plus 5. Notice before I go on what the vertex would be for this, the corresponding parabola. Since x minus h is equal to x plus 1, if I subtract x from both sides, minus h is 1, which means that h is actually negative 1. Alternatively, you could think about this formula as being minus 3x minus negative 1 squared plus 5. And so there's your h and your k. H is actually a negative number. So another way to think about it is just that h is going to be the opposite sign of whatever you see in the parentheses. In this problem we had x minus 3, so h is positive 3. In this problem we have x plus 1, so h is negative 1. So be careful of the signs of h. Okay, anyway, if I want to try and find the alternate version of the quadratic function, all I have to do is just distribute everything. So that shouldn't be that complicated. So let's try that. So if I wanted to find the normal form or the ordinary form that I'm used to seeing, all I have to do is say x plus 1 squared is x plus 1 times itself, and then FOIL and distribute. So I'll FOIL the inside of the I'll FOIL the product of the two binomials. X plus 1 times x plus 1 would be x squared plus 2x plus 1. Then we'll distribute the negative 3 after we finish throwing our markers around. And finally, combine like terms, negative 3 plus 5 would be a plus 2.